and I'm the founder of the NServiceBus project, and we're going to be doing a little bit of spelunking into the NServiceBus project, all sorts of things that some of you might know about, but others might not. Just kind of to get an understanding of where you guys are at. Who here is this the first time that they're hearing about or seeing NServiceBus? Okay. And the reason you're here is because I'm so good looking, or what? Yes? Well, thank you very much. I'll see you at the pub a little bit later. And everybody else, you've seen it. Who's already been using it on a project? Okay, ooh, a lot of you. Okay. And the rest of you, I'm guessing that you're somewhere in between. You might have downloaded and played with it a little bit, but you may not have had the opportunity to use it on a real project. So because we do have a fairly big spread of people that are seeing and hearing about this for the first time, and some people that have seen a lot of it, do a little bit of background in terms of what NServiceBus is. We're going to be spending most of the time today talking about version 2.5, which is the current version of NServiceBus, and the little tips, tricks, and features that you might not know exist and that can make your life a little bit easier. From there, we're going to be talking about the new version that's going to be coming up probably around September, October is the release date that we're hoping, fingers crossed, to have planned. Because NServiceBus is an open source project, we can't always commit and hit the dates, but you know what? All the big vendors out there do it all the time and say we're going to release it somewhere in 2010, and then it turns out to be January 2011. So if Microsoft can't, why can't we? So V3 is going to be, we're going to spend some time talking about sort of the big major features there so you guys can get an idea of where we're going. And then I'm going to open it up for question and answer, so all the things that you've been wondering about. So hopefully that'll be the point in time where if you've had a specific issue with, we did this and it didn't work out that well and what's the best way to go forward, we can answer those questions. Other than that, if I am talking too quickly, if my American accent is too off-putting, it's not my fault. I'm from Canada. We don't take offense for being thought of as Americans, but it's the other way around. Americans don't like being called Canadians. So really quickly jumping into the architectural story of NServiceBus. And for those of you who've seen me talk about this before, I promise it'll be over quickly. For those of you who haven't heard about NServiceBus or seeing it for the first time, it is important to understand that it's not the same as many other technologies that you might have used before or heard of before that have been called an enterprise service bus. So a lot of times when people think about an ESB, they have in their head a picture of some kind of really big box with lots of lines going into it and lots of lines going out of it that is at the center of your architecture. That, unfortunately, is not a bus. That's a broker. And a lot of times people get these two things mixed up, the difference between a broker and a bus. So the primary difference, broker is this big centralized hub and spoke thing at the middle of your architecture. A bus is more federated. Does it mean that it's more federated? You can think of it as something like Ethernet. Okay? So similarly, how you wouldn't expect to have a centralized Ethernet in your architecture, you wouldn't expect there to be a centralized service bus. Just like it doesn't really make sense to talk about sending a message to the Ethernet, you're not going to be talking about sending a message to the bus. All right? The bus, similar to Ethernet, is this fabric that you use to send messages. So you send messages via Ethernet to somebody else. You send a message via the service bus to somebody else. So in that regard, similar to Ethernet, you'd expect to see the bus everywhere. So ultimately, on every single machine in your deployment environment, you'll have some element of the bus. Sometimes it's as simple as just a little DLL that serves as your API for communication. It gives you the ability to publish messages, to subscribe to messages, to send and handle messages. So we'll see some of those APIs as we drill into the details. But the larger architectural concern is that you shouldn't be thinking about physical deployment when thinking about how to design your service-oriented architecture, how to use the ESB. So what we've got here is, although it looks really big and complex and lots of boxes and lots of colors, fundamentally we have two services. We have a green service and a gray service. The fact that green and gray happen to be deployed on multiple boxes, you can think of that just as load balancing. Just like on your regular architectures today, you can have the same web service deployed on multiple machines, and you don't have to think about those multiple machines when you are designing your system. You just kind of plop a box down in your architecture and say, this is my customer web service. So that's the same thing that we have over here. One green service, one gray service. One of them is going to be publishing messages to the other. And it's kind of hard to say what's going to happen at runtime because the messages can go practically every direction. So to give you a feeling for what that might look like is when gray is going to subscribe to green, assuming that gray is our subscriber, it's going to be talking to its bus API saying, hi there, I'd like to subscribe to green's event. At which point in time the bus has this knowledge of where green is on the network, or more accurately, where green's load balancer is. So this DLL would likely send that message to one of the green endpoints. So let's just say that that's this one. So sends a message over here, says, gray would like to subscribe. Notice it doesn't say this specific machine, but rather gray is a logical idea, a logical endpoint. At which point the bus over here stores that information. When I say over here, this endpoint initiates the storage, but the storage is available to everybody on the network. Okay? Kind of like a database that you have today. The bus makes use of a database to store information where everybody can find it. Hello, Skype. Thank you, Microsoft, for your improvements to the Skype user experience. Now we have stored in the bus the fact that gray has subscribed to the green event. Now, when 5 minutes, 5 hours, 5 seconds later, let's say this instance of the green logical endpoint, wow, my green instance is going to the bus and saying bus.publish a certain message. Now, the bus API over here is going down to that shared store. It says, all right, who said that they were interested in this event? And it finds out that gray is interested in that event, not that specific gray node, but rather the gray load balancer. So anytime we are routing, we are always routing to the load balancer. And let's say that this is the load balancer for gray. So when this instance talks to the bus, says, I would like to publish an event, this routes it to this load balancer. This load balancer now decides, round robin or via some other kind of mechanism, to route that message to that green node over there. So it forwards that messages all the way over here. And now we have this gray instance that is going to be processing that message. This is why we say it's not like a broker. There is no central physical place that everything is going to go through. All communication is federated. If one node goes down, all the other nodes can continue operating. It's not like a centralized BizTalk where BizTalk goes down and then nobody else can have those orchestrations available to them. So when talking about NServiceBus, this is the kind of model that we're talking about. Thinking of it as the bus available everywhere, and ultimately it's your responsibility when using the bus to figure out, which publisher should be publishing which messages, focusing more at this logical level, what are my greens and grays, what are my logical responsibilities, rather than physically where am I going to be deploying this. So when thinking about publish-subscribe communication, always focus at that logical level. Don't worry about the load balancing, and NServiceBus has its load balancer to make all of this magic just work. For those of you just hearing about NServiceBus for the first time, is that a reasonable distinction from brokers? Because that's usually the places where people get, by thinking about it the wrong way, they look for the wrong features. Any questions about what NServiceBus is? Yes? Okay. So there's two editions of NServiceBus, and there's the free community edition, and then there's the commercial edition. The main difference is that the commercial edition allows you to scale out and do things like this. The free version is a single machine only thing. Okay. However, in version 3.0, we're going to be bundling the load balancer with the free version as well, so that you'll be able to at least try out all of this kind of scalable pub sub stuff before you decide that you really like it. Okay? Does that answer your question? Okay. Other questions? Okay then. Now let's delve a little bit more into publish subscribe. We're going to be swapping back and forth to code. We're going to be seeing how NServiceBus does pub sub. Then we're going to see some of the more interesting features of pub sub about using interfaces as messages and what that opens up for us. So let's take a look at some code. So over here we have the publish subscribe sample that, so for those of you who don't know, let's start right at the very beginning. You can go to the site nservicebus.com, click the green button that says download version 2.5 now, and then you'll be getting all the things that we're going to be seeing today. In there you'll see the publish subscribe sample, and when you open it up you'll see, let's zoom this in a little bit, you'll see a bunch of projects. You'll see one that has messages in it, another one which is a publisher project. Scrolling down a little bit, we have two subscribers, subscriber number 1 and subscriber number 2. Okay? As you'd expect, the publisher is going to be publishing messages from the messages project, and the two subscribers are going to be receiving it. So I'm going to run this really quickly, putting the subscribers near the bottom and the publisher near the top. Okay, the contrast isn't particularly high, so those of you in the front might see the green over here. Let's actually try to switch the color of these. Let's try. No, that's awful. That. Let's see. Is that an improvement? That didn't do anything, did it? Okay. Well, for those of you who are in the back, it's a little bit hard to see that we're publishing messages, and you might see the scroll bars moving. But as you can see, we can get through quite a lot of messages over here. Basic pub sub, nothing really fancy to have both of these endpoints receiving it. Let me try this one more time, just so that there's a chance you can see it. The colors, oh, that's right, it's using the colored console appender. So that's not even going to help. And I don't want to override that right now. Okay, the more interesting part about pub sub is not the how do I publish a message, because we can see that over here. Ultimately, you just create a event object, and you use the interface of the bus to .publish it. Nothing particularly fancy. On the subscriber side, when you want to subscribe, you handle the message. And also there is an extra little bit of configuration indicating where that message is coming from. So where the publisher is, so that we can contact the publisher and find out where they are in order to subscribe. At this point in time, you may not actually see any kind of bus.subscribe happening, because NServiceBus has an automatic subscription capability that it by default figures out that this message should be subscribed to, and therefore sends it to the right place. If you want to manually subscribe, you can see that being done over here, where you call bus.subscribe for the given event type, and when you shut down, you can also do bus.unsubscribe. Now, one of the things that you might notice here, there's this interface, I want to run at startup. So if you require any kind of bootstrapping code at the beginning of your logic, and we all have that. Every single time that a process starts up, we need to do all sorts of things when we get going. In order to avoid creating those big monolithic static void mains, right? We've all written those that register 20,000 types in the container, and then they start instantiating objects, and it just becomes this big, huge mess. You can divide some of that up by using the I want to run it startup interface and have any number of classes that get bootstrapped automatically when your endpoint starts up. Okay? Now, so this is the manual publish subscribe kind of work. And in the first subscriber, it's all being done automatically. So all you see is the app config indicating where things are, the endpoint configuration. And you might get, over time, you'll get used to this style of API. I configure this endpoint as a server. This indicates that this endpoint has transactional capabilities and impersonation and all sorts of wonderful, neat little features in NServiceBus that make it really robust, and ultimately the logic that is handling the message. So this is the basic pub sub. The area where things start to become interesting is not when we're just publish subscribing any old message, but when we start talking about inheritance between messages. Okay? So when looking at our messages project, what we see here is two messages. First of all, a concrete event message that has a bunch of information inside it, but that concrete message inherits from an abstract interface, the iEvent interface, that looks almost the same. The more interesting thing, and why I'm calling this the hidden NServiceBus gems talk, is because a lot of people are already familiar with the ability to do pub sub. Just define a class, bus.publish, bus.subscribe, and off you go. But that you can also have interfaces, and you can instantiate those interfaces directly. So for those of you in .NET who aren't familiar with this, yes, you actually can instantiate an interface, but it requires a little bit of magic to work. What NServiceBus does at the beginning is, well, I notice that you have a message that is an interface. The nice thing about messages is that they're data transfer objects. So ultimately, it doesn't have any behavior, which means any class can actually be generated that will fulfill this contract, and it will be equivalent to the interface itself. So that's what NServiceBus does when it starts up. It automatically proxies any one of your message interfaces so that when you ask NServiceBus to create an instance of that event, it knows that it should instantiate the proxy that it generated at the beginning. Now, from your perspective and all the business logic code's perspective, everybody still sees it as an interface. But technologically, it's serializing and deserializing as a regular message. However, there's an advantage in having these interfaces around, and the whole idea about having messages inherit from each other, is that we can get the benefits of polymorphism, but not just in terms of object-oriented calling a method and having that dispatched to some concrete type behind the scenes, but rather that when we subscribe, we can choose whether we want to subscribe to the abstract or to the concrete type. And that's actually what we're seeing here. We have one subscriber that is interested in the concrete message, whereas the other subscriber is interested in the abstract. Now, think what would happen when the publisher publishes a concrete message. So based on polymorphism, because a concrete event message is an iEvent, then this subscriber should receive that message, as well as the one that's actually handling the concrete message. However, if we turn it the other way around and say, if we instantiate and publish the abstract message, then only the subscriber that wants to hear about the abstract type should receive it. The one that only wants to hear about the concrete messages shouldn't. if we're to translate this into more accessible language, in OO everybody gives examples with animals and dogs and cats and whatever. You can consider the concrete message as a message about dogs, and the abstract message as a message about all animals. So if I'm subscribed to events about all animals, that means that if you publish a message about dogs or cats or generically about animals, this subscriber should receive it. However, if you're a subscriber that only wants to hear about dogs, if someone publishes a message about all animals, say, sorry, that's too general for me. I only want to hear about dogs. So ultimately, we're getting polymorphism for our publish subscribe. So you can put some breakpoints over here, one of them in this message handler, the other one in the second message handler. And we'll see what happens when the publisher actually publishes a message. Now, the publisher in this case is alternating. One time it's publishing a message about animals, the next time about dogs. Animals, dogs, animals, dogs. So I don't even know which one we're on, but let's publish an event and we'll see. So here we can look at the message and we'll see that it is, let me zoom in a little bit so you can see the type that is implemented over there. You can see it, my messages dot underscore underscore impl dot iEvent. That is the generated proxy type. Saying here you have published a message about all animals. So this subscriber is handling all animals. It's going to receive it. And it does its own logic. But we would not expect the second subscriber to care about this message. So when we press F5, indeed that's it. When we go back to our publisher and say, all right, publish your next message, once again our message handler is invoked. However, this time the message is the concrete type that we saw before. My messages dot event message. So our generic subscriber is receiving it, as well as, when I press F5, the concrete, I only want to hear about dogs subscriber. So we're getting this overlay of the benefits of object orientation, polymorphism, inheritance, on top of publish-subscribe communication. So it's not just about one-to-many communication. How do I distribute a lot of data between a lot of machines? But it enables us to get to a much deeper level of modeling, talking about which specific element of business is the subscriber handling. Yeah, question.
Going back to your original diagram of the bus and
right.
the Ethernet,
Right.
will those two messages be picked up on different machines, or is that, and in parallel? Is that the idea, or?
So, if these are two different subscribers,
Yeah.
okay, they are two different colors in our original picture, okay? Each subscriber is a logical entity in its own right,
Yeah.
okay? So what we originally had in our PowerPoint picture over here was this bit saying
the generic one and the concrete one are two different colors.
are two different colors, which may be load balanced across all the machines in the network. So when thinking about publish subscribe, don't worry too much about the physical elements, about how is a message going to get from one machine to another. Just like Ethernet, the bus will deliver that for you. Don't worry about that. When you need to focus on what are the colors, what are the logical abstractions that I'm dealing with. So in this case, we'd have green, gray, and yellow.
It's
Yep.
just like a simplification, right? Normally you have many more subscribers.
Well, we'd have more logical subscribers, absolutely, in a given business system. The scale of what is on? It's kind of hard to say what the order of number of subscribers is in a larger system. there's no limitation in the infrastructure. It can support a very large number of subscribers. However, one of the things that when I'm working with clients around their usage of NServiceBus, sometimes what happens if I see a very large number of subscribers is that there's this mistake in assuming that subscribers are physical boxes more so than these logical entities. So there can be a large number of subscribers, but I'd say in an average business system, you'd probably be talking about 10 or so. Larger systems will have more, but one of the things that can happen and often does happen is that each one of these subscribers can be a publisher in its own right. So it's not that if you're a subscriber, that's it, or if you're a publisher, that's it. A publisher can subscribe to other messages, and a subscriber can publish its own messages. All right? Does that answer your question? So, is there an example of a subscriber publishing as well? There isn't, but let me show it to you in one line of code. How's that? Good enough? So, in our code over here, we saw, so I'm going to have to stop the sample so I can actually write something. There's nothing at all in this infrastructure that's going to prevent you from saying, you know what, as a subscriber, I'm subscriber number 1. I'm going to define a message, so public class something happened, which is an iMessage. And this thing is going to have a public GUID some entity ID. Okay? And in here, I say after receiving an event called event message, so it wasn't exactly one line of code because I had to add the message, but the publish part is very much one line of code. In here I do I need a reference to the bus. So get that via dependency injection. And in here do a bus.publish, something happened, and put some data in it. Let's see what we have. M dot, what did I call it? Some entity ID equals GUID dot new GUID. Okay? So now my subscriber is also publishing some other event, and there may be somebody else that is interested in hearing about that message, and they subscribe to it. Okay? So you can have subscribers be publishers, publishers be subscribers. Ultimately, what you need to think about is, what do these messages mean? What am I trying to model here? And that's the trickier part, is actually taking a business problem and saying, all right, who is publishing what? But that's not so much about how do you, the internals of NServiceBus, but afterwards, if during the Q&A session we want to start talking about logical modeling and SOA and that kind of stuff, feel free to bring it up again and we'll delve into it. Basic pub sub makes sense? We've seen that? Yes. Now, the more interesting part is when we have these interfaces. See, interfaces give us something that regular class inheritance doesn't. Interfaces allow us to do multiple inheritance. Now, we've all probably heard about multiple inheritance, and people have told us, oh no, that's bad, it's dangerous. If you use multiple inheritance, well, first of all, C# doesn't allow it for classes. The interesting thing that when we're talking about multiple inheritance is only dangerous when you are inheriting behaviors. Right? If I had two base classes that both of them had a method called foo, and in my derived class I invoked foo, compiler says, look, I don't really know which method you want to invoke. And that's dangerous. However, when we're talking about messages, messages don't have behavior. If I inherit from two other messages and both of them have a property called bar, so what? All it's saying is that I too have a property called bar. So multiple inheritance, all the dangerous elements of it, don't hold for data transfer objects. But still the question is, great, so what can I do with multiple inheritance that I can't do with regular classes? Yes? C# doesn't allow you to inherit from two interfaces at that two classes that have that kind of property. When you're talking about interfaces, you can explicitly implement an interface, right? Say, if you are treating me as an iFoo, then you will have iFoo.x versus an iBar.x. And then the various subscribers can still see whatever they want, okay? Now, having interfaces allows me to model my business domain in ways that are a whole lot closer to the real business world. So you've probably been in a situation where you've been on a project, you sat down, you talked to one business stakeholder, and they tell you about the business domain, and they say, the most important thing for us is the customer. Customer goes on the top, and everything else is about the customer and relates to the customer. And you write down all those requirements, and then you go talk to another business stakeholder. So what, the most important thing for us is not the customer, it's the order. We put the order on the top, and everything else goes underneath the order. That's our world. Talk to some other business stakeholder and say, the most important thing in our business is the product. Product goes on the top, and everything else is related to the product. Unfortunately, you can't ever get these guys to agree amongst themselves what is most important, because each one works in some different part of the business. That's the problem with traditional inheritance. You could never get a good hierarchy that addressed everybody's concerns the way that they wanted to address them. With multiple inheritance and pub/sub, you can. If you're interested in the domain of animals, and you say, my whole world is all about animals, so I have a dog lover magazine, a cat lover magazine, and a mouse lover magazine, the Mickey Mouse Club. And that's one set of interfaces, and all these inherit from animal. That's one domain that may have a bunch of specific subscribers for that. And then we may have another part of our domain, another business stakeholder, that says, the thing that we do is all about fashion. And we've got pants and shirts and hats, and all these things are the important part in our business. And they all inherit from some iFashion interface, which is that event type. And you talk to some other stakeholder, and they're saying, no, the main thing for us is about how we go to market. So we have a video game online for young girls where they spend their time dressing up dolls and whatnot, and we've got video games for boys online, which they blow things up, as boys do, and parents that are kind of looking at this stuff saying, oh my God. But having each one of these things modeled by itself is a good first step. The benefit comes in when some crazy guy from marketing said, I've got the most brilliant idea in the world. We're going to create a new what's-it that's going to be a hat for cats marketed to young girls. And we want this new product to appear in our Cat Lover magazine. We want it to appear in the product catalog under hats. And we want it to appear in the video games for young girls so that they can dress the cats in the video game. Now, in a traditional type of class hierarchy, if you try to fit this kind of thing in, often you'll be in this place where you got to kind of break your domain model and bend it in on itself, and it's just not very easy to do. By dividing up your system into these kind of more granular subscribers, each one focused on one specific interface, now we can introduce new dimensions to the problem domain. So we've done market, we've done fashion, we've got animals. Also we can do accessories. And we can do hair care products and all sorts of other things that the business dreams up, and add these additional dimensions of richness to our domain without breaking any existing subscribers. So being able to recompose these interfaces and build new ones and to version them allows us to get a much more loosely coupled system. When you saw the code, it's an extra line of code here, an extra line of code there. It's not about how much we code, it's about that ability to model things correctly. So that's one of those hidden gems that you might have seen it when you downloaded the sample. It said, okay, so you can publish an interface, interesting technical tidbit, but why do I care? It actually is very useful when trying to build larger and larger systems. Any questions about the pub sub with interfaces thing? No? All right. Next one, security and encryption. So there are a couple of elements that and we're going to see them in code in just a second. How you set up security within NServiceBus, how you set up encryption. These questions tend to come up a lot. Later on, we'll talk about how you address the configuration elements so that you get better management for the security in your system. So one of the elements that a lot of people don't know about when doing publish subscribe is some security people aren't that thrilled with PubSub because they're saying anybody could subscribe to anything. Do we really want this kind of data exposure to happen out over the network without any kind of control? And usually the answer that they say is no. That's why we don't like PubSub. So you have the ability to get inside the subscribe process by implementing this interface called I authorize subscriptions. So anytime a subscriber goes to subscribe to a given publisher, you can get a callback. And you'll get full information about what's the message type that they want to subscribe to, which queue are they on and on which machine, the Windows identity, if this is something that is based on who the user that is logged in on that machine is, as well as a whole bunch of header information. So this header information can be used to embed claims from Windows Identity Foundation or from any other identity management system that you have, and to double check on the publisher side, is this somebody that really should be allowed to plug into this? So you get the full dynamic behavior by default. You also get the ability to get in the middle and say, well, hold on just a second. That subscriber for this message type is not authorized. And then it's a simple matter of returning either true or false to decide whether you're going to allow them to connect to your publisher. So that's the basic level of security when we start talking about PubSub. The next level is not just who can see the information when we're talking about publishers and subscribers, but on the wire, how do we make sure that things are encrypted? So you'll see this in the encryption sample, and it's not very complicated. Let's just, I need to remember what changes I made here. To define a message with some sensitive information, use a type that comes with NServiceBus called the wire encrypted string. Okay? So if you're talking about credit card information or things like that you may be sending across the network, even if you're talking about your private network, your LAN, because these messages go through queues, you may not want an administrator or anybody that can see messages on the network to be able to open up that message and look inside and say, oh, great, that's the customer's credit card, and start using it. So we've already heard about, in the past couple of weeks, all sorts of situations where companies have dropped the ball in terms of security and a whole lot of information about customers was exposed. So one of the things that we're trying to do is make sure anytime anything transmits across the wire, it will be kept encrypted. On the client side, when you are sending a message, it's not particularly difficult. You just bus.send the given message, setting which information you want as its secret. The configuration of the encryption bit is where you get to plug in an encryption service. So NServiceBus comes with one built-in encryption service, which is one of the better ones out there. It's based on the AES, also known as Reindl encryption algorithm, which is better than the triple DES. And this is how you get to plug into the NServiceBus initialization bootstrapping. So anytime you want to go into NServiceBus and change some underlying behavior, you can always plug in with the interface, I want custom initialization. You have as many of these classes as you want, each one focused on some specific subset of the infrastructure. In this case, it's saying, let's turn on Rindle because, well, that's a very good encryption algorithm. And Rindle gets its configuration about where is my security key. So the AES encryption algorithm is symmetric encryption. This is not PGP, which is asymmetric. One of the reasons that NServiceBus does this by default is that the assumption is that we're on a local LAN when we are communicating with each other, and we put a higher premium on performance of getting information from one place to another than this ability to do one-to-many untrusted subscribers. So most publishers and subscribers, when working on the same network, there is a basic level of trust. The thing we're more concerned about is if there is somebody else on the network that we don't trust, that they won't be able to see the contents of our sensitive information. So here we've got the encryption service key, which is some 32-bit string. And it's the same both client and server. So both of them are configured to use exactly the same encryption service. Both of them have configured the same key. Client is sending a message to the server, and the server is just outputting the result. So far, so good. We'll run that just so that we can see that the messages go across all right. We'll put a breakpoint over here. And now when the client is available, client sends a message to the server, and the server is able to see the wire encrypted string. So let's just go in there for a second. And right in there in the value, we see that information which says, bet you can't guess my secret, it's my secret. So it gets unencrypted in memory, which is the way that we want, but that's not the part that we're concerned about to begin with. It was more about, well, what happens if the server is offline for a while? So let's kill our server process. The client is still online. Client doesn't know that the server went offline for a bit and is continuing to send a bunch more messages. Now an administrator is going to take a look at the server because he found out, well, the server crashed, I need to pick it up again, and happens to take a look inside that server's queue. So that's the my server input queue, and sees, oh, there are a whole bunch of messages in there. I wonder what's in there. Maybe there's some credit card information that can pay for my next vacation. And they open up the queue and they take a look at the body stream, thinking that they're going to get some secret information. And as they look inside it, what they see is an encrypted base 64 value that pretty much is just a bunch of garbage, and a base 64 IV. This is the way that the AES encryption algorithm structures things. So if you had credit card information or social security information or patient health information, anything which is sensitive and you don't want either external people or internal employees to be able to see that information while it's in transit, all of that is encrypted on the wire. So you don't need to worry about re-implementing this stuff yourself. Let's just bring our server back online so we can get all the messages out of that queue and everything will work as before. Now, and all the messages are now delivered, as you can see. We can refresh the queue and we'll see all the messages have been processed. Now, in a real production environment, one of the things that we know is, well, if we don't change our keys every once in a while, then somebody might have broken our encryption. We're only as secure as how often we change our keys. The more often we change our keys, the more secure that we are. The problem is if we have 20 publishers and 30 subscribers, and each one with their configuration file, going file by file and changing this string from one to the next to the next to the next, somebody's going to forget something. And that's one of the reasons why messages don't get processed successfully. Now with NServiceBus, it's not such a big deal. Anytime there's a problem processing a message, it gets bumped to an error queue, so no information is lost. You always get the chance to try again later. You've probably seen that, but we're going to talk specifically about security. How do you centralize the configuration of your security while still keeping a distributed message processing environment? As we want the benefits of a broker, centralized configuration, but we want the runtime behavior of a bus, everything fully distributed peer-to-peer. So, one of the things that we can do, and we've already seen before this I want custom initialization thing, we can tell NServiceBus that we would like to get its configuration from somewhere else. So what I'm going to do is, currently I'm just going to put this in the messages project, so we have a central place that both of them already reference. So I'm going to have my public class my config source, which implements the interface iConfiguration source with NServiceBus. I think we need the reference to the binaries in servicebus.core. Maybe now it's going to be nice with me. All right. So in the configuration source, I have the ability to override any specific element of configuration. So I may decide I want to override everything and get all my configuration from one place. Or I can decide, you know what, let me just get the Reindl encryption service. So we saw that in our config over here. We have the Reindl encryption service config. That's the thing that we want to override. So we're going to check if the type of configuration is the same as the type of the Reindl encryption service config. Then we want to go get it from somewhere. In this case, we could just return it from something in memory. Reindl encryption service config, setting the key equals to whatever we want. So we can take this and hard code whatever we had over here, put it in one place, and have everybody reference the same thing. And then in here we'll have just the regular return. I need also the configuration manager. It comes with .NET, system.config, return configuration manager, and get the config section of T, where we get the type of the T by name as T. So what we've done is we've told NServiceBus, I want to get your Reindl encryption service config from somewhere else. Everything else, revert back to the generic config file. Now you could have pulled this information from a centralized database using link to SQL or something like that. You could have called a centralized web service where the web service is holding on to this key. Any central place that you want, and then changing that key from that one central place and having everybody feed off of it in a distributed manner. Yeah, question? So that's an excellent question that I would like to table it for just a bit. We're going to talk about it in the next section, which is about profiles. Okay? So we're going to get there. So a lot of the things in NServiceBus that sometimes people try to, publish, subscribe some information at an infrastructure level and then to cache that in memory, sometimes just re-implementing things that they didn't know were there. The ability to centralize configuration, the ability to centralize logging. You have the ability to go several layers deep into NServiceBus, take its default implementation and make it work totally differently without having to redo any kind of top-level pub-sub work. So here we've got the config source. Plugging the configuration source into each one of our endpoints is done like this. So on the client, as a part of our I want custom initialization, we're actually going to do it at this level. I want custom initialization. Where in here, we're going to introduce NServiceBus to its configuration source. So NServiceBus.configure with, and we're going to use the custom config source. New, what did I call it? My config source, I think? Yes. My config source. And I also need to include the rest of the information that comes as a default, which is my default builder and the .xml serializer. Okay? So now I'm using the configuration source to get this information on the client, and I'm going to do the same thing on the server. So once again, overriding the I want custom initialization and telling NServiceBus that it should use that information we had over here. Same thing over here. Okay? So just to make sure that this works, we're going to comment out the Rindle encryption config section that we had over here and also at the top so that it really will work the way that we expect it to. And yes, this is pretty brave on my part doing live coding, but hopefully I've done this enough times before that I remember all the things that need to be done. It's really not a lot. You'll be doing this once per project. So we've got everything all set. We're going to run it. I'm going to cross my fingers and hope and pray that all of it goes through all right. In this case, we're once again using the hard-coded key. So we're going to make sure that both of them have the same key. But like I said before, this could come from a web service or anywhere else. So we've got client talking to the server, and message arrives at the server, and we are able to decrypt it successfully, even though now we're getting all our configuration from a central place, which, like I said, database, web service, whatever. So this can make the lives of your administrators a whole lot easier. And NServiceBus tends to have this kind of thing. When you as a developer download it, it does everything in a very simple, straightforward manner, leaving everything in the config, so you can fiddle with things and learn as you go. But it always has these 2 or 3 layers down, those hooks that you can get in there and give you a more manageable production environment. Any questions about the centralized configuration, encryption, and how these things will work together? No? Yeah?
The entire message, or do you need to use the different specific types of encryption?
So the question was, can you encrypt an entire message? The answer is yes, but not yes but, yes and. Okay? So usually when you're in a LAN environment, if someone has hacked your LAN, encrypting the whole message or not encrypting the whole message is kind of besides the point, because they can get into your running code and then see the message as it is unencrypted. So the primary context where we're interested in encrypting the whole message is when we're transmitting the information from one LAN to another. We have something at our head office that we want to transmit to a branch office, or vice versa. So when we're talking about that kind of inter-site communication, NServiceBus has a different capability. It's called the gateway, that allows you to bridge one site to another site. And you can configure the gateway to run over HTTPS. So that way you get the full transport level encryption. So that's the recommended default topology architecture and configuration to give you the full level message encryption where it makes the most sense. If beyond that you want to get to a lower level of NServiceBus and say, yes, I understand all that. In this specific case, I actually want to make NServiceBus encrypt the whole message. In version 3.0, we have hooks called message mutators. So you can get into the pipeline when NServiceBus is sending a message and say, hold on just a second, let me take that message, encrypt it using whatever means that I want, and then send this instead to the other side. On the other side, you write a message mutator which does the inverse. Get the encrypted message, decrypt it, create a new message object, and pass that one along. So you will have the ability to get into that lower level pipeline to do that in a LAN environment, but you have to work with a slightly lower level hook of NServiceBus. Okay? Other questions? Am I going too fast, too detailed, not detailed enough? Okay, good. Now, we can go and talk about our next topic, which is profiles, which is exactly what Dylan asked me about. So, the context of your question, before you said, how do I do this, or in terms of the getting all of the configuration of which messages are going to be routed to which queues. So your desire to have that centralized was so that when you move a system from dev to test or from test to production, then you don't have to fiddle with a whole lot of configuration files. So a big component of the way that NServiceBus works is we do take a very life cycle friendly view on the design of the infrastructure. In other words, things that make sense when you're running on your own developer box don't really make sense in a production environment, and vice versa. So before I answer the specific question that you asked about how do we deal with the configuration of message queues and messages from one environment to another, talk more broadly about this moving a system based on NServiceBus from one environment to another. So there are certain features of NServiceBus related to fault tolerance that when you as a developer are working on your own machine, you don't really care about. For example, when you're doing pub/sub, you press F5 in Visual Studio, everything starts up, you debug until you see that everything's working okay, and then you stop debugging. You don't actually need to have the publisher in a fault-tolerant way remember who all the subscribers were in case they crashed and started up again. That's irrelevant on a developer machine. So in-memory subscriptions make sense on a dev box. However, in a production environment, or even on a tester environment, we may want to try out, is my system reliable? Is it fault tolerant? At which point in time, you may want to have more durable subscriptions. So NServiceBus has multiple profiles. The three main ones are called light, integration, and production. Under the light, which is the default, everything is held in memory. So it gives you a very nice, lightweight, fast, debug-friendly experience. In the integration environment, the subscription list is held in a queue. So that means that when a single tester is testing your system out, they can run everything locally. You don't need any special installation, and NServiceBus automatically creates queues when it needs them. WCF, for those of you who've worked with the NetMSM binding, doesn't. So it gives a fairly good tester experience of getting a system up and running, so even if things crash in the middle, we can continue our test process. Then there's a production environment, where, as we said in this picture over here, we'd actually like to have the list of subscribers be accessible to everybody on the network. In which case, NServiceBus in the production setting uses a database as its subscription storage. So the profile feature of NServiceBus allows you to say, NServiceBus, now I'm in this environment, choose the appropriate set of infrastructure for this environment. Now, the way that you set that is very straightforward. We'll switch back to our pub/sub example so we can see it in action. It's done via the command line. So when we're moving a system from one environment to another, the last thing that we want to do is to have to change either code or configuration. Anything which is manual and that we need to remember to do, somebody's going to forget, and then we're going to end up with the wrong permutation of infrastructure for that environment, And until somebody figures out what the hell went wrong, which config file did the wrong person touch, it's going to take forever. So that's why NServiceBus says, let's create these named environments called profiles and have the ability to hook into them. So by default, when we don't run anything, it's just doing everything in memory. So I'm going to run this really quickly, and as it gets started, we'll talk about, again, this subscription storage element. So when we have our subscribers, when they start up, they communicate with the publisher, telling the publisher, and we'll see messages arriving over here, hello, my name is so-and-so and like to subscribe to your event. Now, let's get rid of the breakpoint so that we can see the fault-tolerant story in action. And second breakpoint is now gone as well. What happened here? Cannot publish to the endpoint. No subscription storage. The reason for this is NServiceBus is telling you, and unfortunately the guy that asked this question before it left, we have configured an endpoint to be a server. It's doing a bus.publish. And it's saying, wait a minute, I'm not actually configured to be a publisher. I don't have the requisite infrastructure in place. So if somebody came to me and asked me to subscribe, this wouldn't work. So the one thing that we need to change over here in subscriber number 1 in order to publish successfully is not as a publish in our endpoint config. So you say, I'm configured as a server, not as a publisher. And if you don't remember this, you can't just publish by accident. Publishing means something. So we're going to change this and be as a publisher rather than as a server. So in this case, it doesn't really matter because nobody is subscribed to its events, but still this is NServiceBus giving you that sanity check, making sure that everything is configured correctly. What you might notice here, you got this yellow warning, it's noticing that it's missing a subscription queue. So what NServiceBus does is saying, you probably should have configured my subscription queue, but because we're running on in a developer profile, don't worry about it. I'll create it for you. You go about your business debugging matters. However, if we were in a production environment, it would say, no, stop the show. We don't automatically create things in a production environment. An administrator should have set this up. So now we have our publisher that is publishing a bunch of messages. Everything's working okay. Now the publisher crashes and starts up again. And what we'd expect to happen in a production environment is that the publisher should remember all of the subscribers. However, in this situation, one of the things that you might notice is now it's publishing and these guys aren't moving. Why? Because in your light profile, NServiceBus says, I don't need to be fault tolerant. This is a dev box. If you want to change that, you have to tell NServiceBus, you know what, we're not on a dev laptop anymore. Now what you need to do is to get yourself ready for integration testing. So you're going to run the same process as before, bringing up the publisher, bringing up the subscribers, crashing the publisher, bringing the publisher back up again, and we'll see that this time it remembers. So that's one thing, as this is getting ready, that is different when we move our system from a developer's box to a tester's box. Now there are all sorts of other elements of NServiceBus that have that same kind of behavior. When you are logging, for example, it's very useful on a developer box to spit out a whole lot of information to the log. When you're on a tester box, sometimes you want to dial down the level of logging. So instead of logging at a level of info, you log at the level of warn. Instead of possibly logging to the console, you want to log to a file so that if there is a problem, you can collect the log files at the end of the run. So NServiceBus has this kind of capability where you can go in there and say, I would like to configure logging for a given level of profile. So let's just do this process again. Publisher is publishing a bunch of messages, cause the publisher to crash, bring the publisher back up again. And when the publisher comes back up again, we'll notice that once again it remembers all of them. So NServiceBus has lots of infrastructure pieces, like where it's persisting its sagas. There are long-running processes that are supported by NServiceBus that are called sagas. By default, they're stored in memory. If you're talking about a production environment, you're going to want them stored in a database. So NServiceBus has all of these optional pieces of infrastructure, some of them suitable for dev, some of them suitable for test, some of them suitable for production. And by switching that command line, you can get those different behaviors. I'm going to be getting to your point in just a second. But another question. Yes. Similarly easy in that it is the exact same thing. So one of the things that you might not have noticed when looking at NServiceBus is that all of these projects, let's zoom in here really quickly, aren't executables. This is a class library project. So the executable here is actually something called NServiceBus.host. And when you tell NServiceBus, when you press F5 in Visual Studio, you'll notice here it says Start External Program, and it's invoking that NServiceBus host. Now, the NServiceBus host is this generic host that by default runs as a console application and makes it very easy as a developer to set breakpoints and to debug into it. But it also supports installation as a Windows service. So you just say nservicebus.host.exe/install, you give it the Windows service name, you give it the username and password that you want it to run under, and you provide all of the profiles. When you do that, the Windows service bakes into it that command line so it remembers. So yes, there is something similarly easy. Okay. So these are little things that once you know that they're there, it means you don't have to reinvent those wheels. Now, that's not just for NServiceBus functionality. You can hook into these profiles yourself. So who has the need to send email in their application? Email. Is anybody sending email? Yes. Just a couple of you. It's fairly likely that when you are running the system on your own dev machine, you don't actually have access to an SMTP server, and quite frankly, you don't want real emails to be sent while you're just debugging your app. So one of the things that you can do is hook into the NServiceBus profiles. So let's just put this, say, over here, making some room. So you can say, what I'd like to do, so stop debugging, is I'd like to register in the, so let's say we have some email sender. So let's just create that interface. Public interface email sender that has one method on it, public void send email that accepts some kind of string. Okay? Without public. And in your publishing code, let's say in your server endpoint, over here you have injected your public email sender object. Now, one of the things that you want to do is saying, when I'm running on my own dev machine, I want a log output email sender. In other words, every time I say send an email, what I really want to have happen is something to write to the log right in front of me saying, I am sending an email and here's the string. So let's implement that interface with our public class logging email sender, which is an email sender. And what we have in here, you know what, let's just do a console.write so it'll be easier. Console.writeLine with the string. Okay? Now we may have other implementations, but now what we'd like to say is when this endpoint is running under the light profile, register in the container the logging email sender. When it's running in the integration profile, register some other email sender to the container. When it's in production, plug in the real SMTP sender. So we can do it like this: public class, my email bootstrapper, which implements the I handle profile of T, where T in this case is NServiceBus.light. So your class is going to be activated at startup when we are running under the light profile, and then you can get access to the container. So we have a generic wrapper for the container via the configurer that allows you to get into the configuration instance configurer object and say configure component of T, where T is your logging email sender, and you can configure it as the singleton that it needs to be. Okay? So we're going to put a breakpoint over here and inside our server endpoint over here, just so that we can see when we are going to publish a message that the appropriate email sender has been bootstrapped. Well, actually, in this case, my apologies, we still have left over what we said before in NServiceBus.integration. Right? So we're currently running it under the wrong profile. So let's return it back to the previous profile. Quickly just run the publisher. And one of the things that we see is, here it is, your email bootstrapper has been invoked by the infrastructure. It says, oh, okay, you said you wanted to handle this profile, have at it. And in here saying, all right, let's go shove my logging email sender in there, F5. Now when I say send a message, I can take a look at my email sender object, and I can see that it is the mypublisher.logging email sender. So all of the other objects inside my endpoint continue to use the regular dependency injection. They don't need to change. We don't need to change our config file. Right? We can have one single config file that doesn't change when we move from dev to test to production. The only thing that we're changing is that command line switch, where the rest of our code base says, oh, okay, now we're in integration. Let's do this for email, and let's do this for writing to a database, and let's do this for calculation, and let's do this for whatever. We can have our entire code base move from dev to test to production without any of those config changes, or needing to have an entire config file. This is for my developer machine, and a separate configuration file for this, and a separate configuration file for that. So this isn't just for NServiceBus configuration. You can have the rest of your app be lifecycle aware the same way that NServiceBus is. And you saw it, not a whole lot of code to plug into that. Now to your question that you started out with. What about the parts of the configuration? Like, well, it's not so much on the publisher side, but on the subscriber side, things like where these messages need to be subscribed to. So which message is going to which queue and on which machine? So I've got two answers for you, the two-phase answer. Number one, the recommendation is that your integration environment, or let me start this way. A lot of times people haven't spent the time to talk to their network engineers about the topology of their network. The best recommendation is to say, why would I want to change the machine names or the queue names when moving from test to prod? Network engineer, please give me a subnet for my integration environment and a separate subnet for my production environment. Quite frankly, these two subnets should not be talking to each other very much. So we may even want to have a firewall there so that data doesn't accidentally go from one to the other. Once we have these two separate subnets, we can have exactly the same machine names in each subnet. In which case, it would be exactly the same configuration. Exactly the same machines in both environments, exactly the same queue names, don't have to change anything, don't need to centralize the queue names so that you could change them from one central place. So that's the architectural answer of why you shouldn't and don't need to do that kind of thing. And the answer, and because we're kind of getting close to the wire, the Skills Matter guys told me to finish at 8 o'clock, and we didn't even get to the cool 3.0 stuff. So I'll start sprinkling that in already. Is, here we are, the new zero config model for 3.0. And no, you don't want to divide by 0. The zero config model that we're going for 3.0 is based on discovery. So NServiceBus is going to have the ability to talk to the various endpoints that are NServiceBus on the network and say, which messages do you handle and which messages do you handle? Oh, you handle those, I handle these. And to actually propagate all this information, who is where on the network, so that when you say bus.subscribe to a given message, it says, oh, I know who's responsible for this message. It's that endpoint. And then it'll go send the message over there. The purpose of this zero config is not so much for production. The last thing that you want is for a system to dynamically discover the wrong thing in a production environment and start sending messages where they shouldn't be. However, for a developer environment, saying, I'm just building the system. I don't want to think about what's the name of this queue and what's the name of that queue and how do I route this message to that process. All I want to do is start up 5 endpoints and go, and to have it all just work. So that's what we're going for in the next version, to have this ability to find out where everybody else is on the network and to have all of that routing configuration disappear. What do I mean by disappear? Built automatically. The next thing will be, when you are moving from dev to test to production, that you can freeze your environment. Say, take all the configuration that you have generated on your own and give it to me. When I'm in production, I actually want to specify where everything is and to double check that this is what I want. So it'll build that configuration, then it'll spit it out to a file, and you can decide whether you want to keep that. When you're in your light profile, usually the answer is no, I'll do something else and switch other endpoints on and off until I'm kind of happy with it. So reducing the friction of developing in an NServiceBus environment. This is not only for the routing information, also for where is my load balancer. So it's going to be able to know where the appropriate load balancer is and to connect to it automatically. It also is going to know where the gateway is. We talked about the ability to communicate between sites. So where is the gateway on this site? Where is the gateway on that site? To have all dynamic discovery happen, so everything just magically works, at least when you're working on your developer machine, and you don't yet know what the system actually has to do. Also in the next version, we're plugging in RavenDB. So RavenDB gives for an even better, more seamless developer experience, because things like subscription databases, who really wants to set up a SQL Express on their box and have to define the subscriptions table and go to the config file and tell nhibernate, this is the connection string, and yes, by the way, it's SQL 2005, and this is, all of that crap. We're removing that by working with RavenDB by default. Keep in mind, everything that we do in NServiceBus, we try to have intelligent defaults, but you can always swap out the implementation later. So we're plugging in RavenDB. For those of you who are wondering, yes, RavenDB needs to be licensed as well if you are using it yourself. However, we've struck a deal with the company behind RavenDB so that when you buy NServiceBus, you will have already licensed RavenDB as well, both for your dev and your test and your production environment. So you don't have to license them both. You buy one, you get it all in the same box together. That's with regard to RavenDB. It's going to give you a much more seamless experience. Windows Azure is the next big thing that's also been coming in version 3.0 for a while. So we've swapped out all the on-premise infrastructure of NServiceBus. We plugged in Azure queues. We've plugged in App Fabric queues. Why? Because Microsoft decided to have two queuing infrastructures in the cloud and confuse the rest of us. Hey, when should I use which one, and which one is more expensive? So Azure queues, Azure table storage, Azure blob storage, Azure SQL storage. All of these crazy permutations, we've swapped out all the NServiceBus infrastructure and built it on top of Windows Azure. We've got a Windows Azure MVP that's been nagging the Windows Azure team to fix all sorts of things so that you guys don't need to know about it. So you just tell it, NServiceBus run on top of Azure, and say, well, the smartest thing for me to do, the most low-cost model, is to use Azure queues, not App Fabric queues, to use not the SQL Azure storage, not the blob Azure storage, but the table storage. I'm sure that some of you didn't know that the table storage is actually the cheapest storage that you can currently get with Azure. So it's going to get all this stuff configured for you out of the box. Obviously, you'll always be able to switch around what's in there, but it's going to give you that ability to have the same code base that you're running on-premise also run in the cloud without you becoming an expert in Windows Azure. We've also got all sorts of knobs and things that you can change the NServiceBus behavior around how often it polls for messages. So in Azure, the more often that you poll for messages, the lower latency you'll have for message processing, but you're paying more. So ultimately, that's going to be up to you. How often do you poll for messages? The default that we have is we've got an exponential backoff. So we look for a message in the queue. If there is a message in the queue, then we assume that there's going to be another one shortly after, so we're going to poll quickly. If there is one, great, we keep polling quickly. If the queue is empty, then we say, well, hold on a second, let's wait a bit longer before we come back. Then we come back later and say, oh, there's still no message, we're going to wait even longer before we come back. So try to keep the cost to you as low as possible based on the current load. So if you have load that goes way up and then goes all the way down to zero, and way up and all the way down to zero, yeah, we're going to have a hard time giving you both low latency and low cost. But for most reasonable load profiles where you might have spikes, but you kind of always have some messages in your queue, it will be good enough. And when the queue empties out, it will empty out for a while, it'll dial back the load. So these are the kinds of things that we're baking into the infrastructure to get you started on Windows Azure in the best way possible. Zero config I already mentioned. And with that, I'll open it up for questions and answers in the several minutes that we have left. Anything and everything that you'd like to ask me about with regard to NServiceBus, past, present, and future, or anything else for that matter. Yes?
There was a statement we made in a blog post back in April where you said the...
Oh, that one, yeah, I know.
You could give us that
I
you were
don't.
doing CQRS...
Where are my guys in my course? I've got a couple of guys from my course that just went through that mind-bending session today. Okay.
What was the question again?
I said, he was referring to a blog post where I said, when you do CQRS correctly, your aggregate roots are sagas.
I was going to ask if you could just expand on that a little bit.
How do I expand on that a little bit without cramming 4 days of the course, and when it really is a lot of information. Let me get, so this is going to be recorded, so you're going to be able to listen to this 2 minutes over and over again until maybe you'll understand. So I'm going to try to make it concise. CQRS makes the most sense in a collaborative domain. If you're in a non-collaborative domain, you don't really need commands and queries being separated in domain models. It's usually a whole lot more persist data, show data to the same user that entered it in. So think about a user's profile information. First name, last name, middle initial. Your entire logic is take the data from the UI, shove it into a database, and present it back again. You don't need CQRS for that. Keep it simple. The area where you use CQRS is where you have multiple users in parallel that are operating on the same set of data. Okay, so in this collaborative environment, what you tend to uncover is race conditions. User A did this and user B did that, a millisecond before or a millisecond after. And now how do I handle these kinds of race conditions? Now, anytime that you see that you have this kind of race condition between users in a collaborative domain, there tends to be some business concept that hasn't been explicitly modeled. You go digging for that business concept. Usually it will appear as a long-running process. And sagas are the exact pattern that is used to implement long-running processes. So that's why I say, when you look at what your domain logic is in a collaborative domain, it tends to be all about what is the long-running process that governs the collaboration between users, and that is a saga. Okay? Other questions? Yes, sir. Okay. So I gave a recommendation, and I still give the recommendation, that you should design your NServiceBus system so that each message type is processed or goes to a separate queue. So you should look at partitioning your message types into many queues rather than having all the messages go into one big queue. And a lot of people, like yourself or like your manager, raise an eyebrow saying, well, this looks like I'm going to be having lots of queues, lots of endpoints. It feels like that would be more difficult to manage and to administer than if I just put everything through one queue. Now, we also covered that today in the course. I'm going to give you the short answer for them. Don't you guys feel smart now? So the idea of what it means to administer a system, there is the, how do I install it? How do I collect the CPU information, the memory information, all that kind of stuff. Where one of the more interesting questions to address is the business question of which use case in my system is the slowest? Where are most of my messages backing up? Is it in handling purchase orders? Is it in handling reports that I'm generating? Is it in handling these kinds of queries? Where is my load? Now, if you have all of your messages inside a single queue being processed by a single endpoint, you say, okay, I see that there are 317 messages waiting in this queue. But how many of which type, I don't know. So I can't really answer the business question, which is the valuable question. Which use case am I behind on in my system? Also, when I want to talk about scaling my system, I don't necessarily want to scale the report generation part of my system. I'd like to have the report generation off on its separate endpoint and add hardware behind my load balancer only for the purchase order part of my system. So when I talk about monitoring which part of my system is slow, having separate message type and separate queues gives me that business level visibility. Once I know which part of my system is slow, then I can throw hardware at that specific problem without wasting that hardware somewhere else. So at first blush, it appears more moving parts would be more difficult to administer. But when we look at the business objective of what's slow and how do we make it faster, it serves that a whole lot better. And that's why I give that architectural recommendation. Okay? All right. Any other questions? All right, well, if there are others and you want to ask them one-on-one, please feel free to come up. If you are looking for more information, there's a fair amount of documentation online on NServiceBus.com, and we have a discussion group where we've got over 1,200, 1,300 people there that are all asking and find just about any answer to any NServiceBus question that you're looking for. And with that, I'll thank you all for hanging around and hearing all about NServiceBus and the hidden gems inside it. Thank you very much.